So we need to find the molar mass of lead 4 sulfate. So you need to know what the actual formula is before we do this. So lead is Pb, and 4 is plus 4. Because it's a transition metal, we use the Roman numerals to give us our charge. And remember, it's a positive charge, plus he's in the front, so he's our cation. Sulfate, we're going to get off the poly sheet, SO4 minus 2. Polys get parentheses. Don't say, oh, there's a 4 and a 4, so I'm done. You do have to crisscross. 4, 2. So I rewrite Pb2, SO4, 4. And then I look at that and go, wait a second, 2 and 4 can be adjusted. I can simplify that. I can divide both of these guys by 2. Polys get parentheses. You cannot simplify what's inside the parentheses. So that stays SO4. And you reduce the outside. So it's now Pb SO4 2. If you don't do that, you end up with the wrong number for lead 4 sulfate, and it's going to mess up the rest of your problem. So do make sure that you simplify outside the parenthesis when you're able to. So this means we have 1 lead, because remember, you always assume there's a 1 out there if you don't know, and you assume there's a 1 next to the element. There are 2 sulfurs and 8 oxygens. Okay, so this is helpful even if we're not balancing. You still have to go through and be able to count those number of atoms. When I look on the periodic table, see if I can get this to work right. Lead 207.20. Remember, 82 is the number of protons. 207.20 is the number of protons and neutrons. So that's its atomic mass. So that's the number what I need here. 1 times 207.20. 2 sulfurs. Sulfur, 32.07. And 8 oxygens. And oxygen has a mass of 16.00. Okay, and now I just need to plug that all into my calculator. Oops. And make sure you plug it in correctly or you're going to get the wrong answer. All right, I'm going to type it in again. 207.2 plus 2 times 32.07 plus 8 times 16.00. And that's going to give me a total of 399.34, always the 2 decimal places. Okay, so 1 lead at 207.2, 2 sulfurs at 32.07, 8 oxygens at 16.00. And so then my molar mass is 39.344. And if I want to put that with the proper units, it's 39.344 grams per 1 mole. And we'll need to know that when we are doing our stoichiometry.